Assalamualaikum and hello everyone. Welcome to the video where we will be discussing past year question for the year of 2018-2019. In this video, we will discuss question number 3 involving chapter 4 chemical bonding. Question A, ammonia, NH3 and boron trifluoride BF3 are covalent compound. NH3 and BF3 will react to form NH3 BF3. Question 1 Roman, explain why NH3 obey the octet rule but BF3 does not. Okay, so first what we like to do is actually we will draw the Lewis structure for NH3 and BF3. So to draw the Lewis structure, we have to know the valence electron lah for each of the atom here. So how to know the valence electron? You must refer to the list of constant to know the number of proton, and you must write down the electronic configuration first. So this is the electronic configuration for the atom. Okay, so next is to determine the valence electron. Again, valence electron is your highest n. For nitrogen, your highest n is n equal to 2. Your valence is 5. For the case of hydrogen, your valence is 1. For your boron, highest n, again n equal to 2. But here your valence is 3. For your fluorine, again your highest n is n equal to 2. But how many valence electron? We have here 7. Once we have determined the valence electron for all the atom, then now we may count the total valence electron to draw the Lewis structure. So we may start with our NH3. Nitrogen have 5 valence electron, hydrogen has 1, but then this case we have 3 hydrogen, so total is 8. So which one is our center? Center is the least number of atom in the molecule. NH3, the least is our nitrogen. So nitrogen will be the center and it will be connected to all our atom, which is this case terminal is hydrogen. Then again, remember that for each one bond means that we have 2 electrons. Since we have 3 bonds, so minus 6 electron. So we have total is 2. Okay, so usually the remaining electron we will put on the terminal atom. But then for the case of hydrogen, maximum number of electron is 2, duplet. Each of the hydrogen already got 2 electron. So we don't have to put any electron on the hydrogen atom lah. So where should we put it? We put it on our central. Okay, then we have 0 electron left. Then we check whether all the atoms achieve octet or not. Hydrogen only achieve duplet, so it's fine. Okay, next one we're gonna draw for the BF3. Boron got 3 valence electron, fluorine got 7, but there's 3 of our fluorine, so 21. So the total electron is 24. Again, the central atom is the least number of atom in the molecule, so boron is connected to 3 of our fluorine. Okay, and then we're going to minus with 6. Why? Each one bond means that we have 2 electrons. So minus 6. Now we have 18. So make sure that first we have to make sure that the terminal atom achieve octet. In this case, hydrogen, just now, because hydrogen maximum is 2 electron. For fluorine, again achieve octet. Right now, fluorine only got 2 electrons. So it needs 6 more. Each of the fluorine needs 6 more electrons to achieve octet. So, okay. The total electron used is 18. So when we minus, we have 0 electron left lah. So this is our structure. So fluorine already achieved octet, but boron haven't achieved octet yet. 6. Okay. So usually if the atom haven't achieved octet, it will share, the terminal atom will share the lone pair to form the double bond or the triple bond. But in this case, again, back to the question. NH3 obeys the octet rule, but BF3 does not. So it means that this is the structure lah. Again, there are atoms that does not obey the octet rule, which is the incomplete octet. Incomplete octet hanya for berbal, beryllium, boron, aluminium. So again, this is B, our boron here lah, yang berbal ni, in the middle ni. So it's fine lah. Okay. So this is the case for NH3BF3. So this is the drawing. Then we have to explain. The question asks to explain why. So first for our NH3. So N has 1, 2, 3, 4, 5, 6, 7, 8. So here NH3 obeys the octet rule. So the first statement is about our NH3. So we mentioned that in NH3, the N nitrogen contains 8 valence electron. Hence the NH3 obeys the octet rule. Okay, that is for the NH3. Next is for the BF3. So for the boron, it got 1, 2, 3, 4, 5, 6. And then we have to explain about the boron lah. In BF3, B contains only 6 valence electron. So in this case, BF3 does not obey the octet rule. Why? Because it is incomplete octet lah. We can mention that does not obey the octet rule, or it is BF3 is our incomplete octet. Okay, so that is for question number 1. So to explain, actually you have to draw first. Then once you draw, and then you can see lah, for the N, it will achieve octet. For B, does not. Okay, so that's for question A. Question 2 Roman, show the formation of NH3 BF3 molecule using Lewis dot symbol and label the bond form. So again, our NH3 and BF3 is covalent compound. That's why we draw the Lewis structure lah. But right now, this NH3 and BF3 will react to form this molecule. So what's the bond form? This is actually, okay, for our syllabus, we learn about ionic bond, covalent bond, and last but not least is the dative bond. Ionic usually between, for example, NaCl, MgCl2, or the ionic lah, our salt. Covalent is as mentioned previously, BF3, NH3. For this case, NH3, BF3 here is actually our dative bond. Okay, so what is about dative bond? Dative bond consists of donor and acceptor. Okay, for example, I have my ionic. Ionic, I have a transfer where one will gain, one will lose. For example, I have NaNCl. So Na will transfer one of the electron. Okay, so this is for the ionic. For the covalent, we will share the electron. For example, my fluorine will share one of the electron each lah. Okay, to form octet. Okay, but then for the case of dative bond, we need one donor and one acceptor. Where covalent, each of the atom will share. Okay, so but then this case, dative bond, as if covalent they share, tapi only one will share, our donor. Okay, acceptor ni pula, dia accept lah. Okay, so how to know which one is donor, which one is acceptor? Donor is the one we have the lone pair. Acceptor where the atom is incomplete octet or empty orbital. Okay, so from the previous step, we have draw the shape or draw the Lewis structure. So now we must determine which one is donor, which one is the acceptor lah. So it's either these two. Okay, so for example, for the donor, okay, it must contain lone pair. As we can see, this case, our nitrogen atom contains lone pair. And then for the fluorine also contains lone pair. So donor we're not that sure about. Okay, then let's check for the acceptor. Acceptor either incomplete octet or empty orbital. So for the hydrogen, okay, hydrogen memang maximum 2 electron kan. So dia duplet lah. So yang ini kita biarkan sahaja. It's not donor, it's not acceptor. It's not donor, why? Because I have no lone pair. But it's not acceptor lah. Dia bukan incomplete octet. Memang hydrogen is duplet. Okay, then fluorine ni pula memang dah cukup. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then we check boron. Boron 1, 2, 3, 4, 5, 6. So boron got 6 electron. So 6 electron means that it is incomplete octet. Again, verbal incomplete octet. So this one will be our acceptor. This one will be our donor. Specifically, which one is our donor? Our nitrogen, the lone pair here will be the donor and the acceptor will be our boron. So the question show the formation of NH3 BF3 molecule using Lewis dot symbol and label the bond. Okay, so now we have to show lah the electron is being shared to the boron. So how do we draw it? So this will be the drawing where again we must show that the electron is from the donor to the acceptor lah. So here I show you in my donor, the electron is from my donor, which is nitrogen specifically, towards my boron. Okay, so this is one of the ways to draw it. If you want to draw it this way pun boleh. Just make sure that the arrow must be from the nitrogen towards boron. Okay, so that is our dative bond. Okay, don't forget, last but not least part of the question, label the bond form. So the bond form is dative bond. So we have to label this is my dative bond. So that is the solution for question 2 Roman. Again, since this case does not mention specifically about shape or molecular geometry, then you don't have to follow the shape lah. This one asalkan Lewis structure pun boleh. Okay, so that is all for question A. Question B, oxygen difluoride is a strongly oxidizing colorless gas. 1 Roman, determine the molecular geometry of this molecule. Okay, so to determine the molecular geometry, you have to draw your Lewis structure. So again, first thing first, we have to find the number of proton for the oxygen and fluorine to determine the valence electron. From the electronic configuration, we know that the oxygen has 6 valence electron, whereas the fluorine has 7 valence electron. Okay, next what we have to do is we have to calculate the total valence electron. Okay, oxygen got 8 electron, fluorine got 7, but then we have 2 of it, so 14. So total will be 22 electron. Okay, to determine the central, it will be the least number of atoms in the molecule. So oxygen is our central connected to fluorine. So each one bond, we have 2 electron minus 4, 18 electron. Next, we have to make sure that the terminal atom already achieve octet. Right now, fluorine only got 2 electron. So it needs 6 more to achieve octet for both of our fluorine. The electron used is 12, so we have 4 electron left. So where do we put the electron? Okay, we put it on our central. Okay, minus 4. Once we put the remaining 4 electron on the oxygen, so we have 0 electron left lah. So now we check whether all the atom already achieve octet or not. So here fluorine 8, oxygen 8, fluorine is 8. So this is the Lewis structure. So next what you have to do, based on the Lewis structure, you have to know your class. So class is A, B, X, E, Y. A stands for your central atom, B bonding pair, E lone pair. In this case, our oxygen is bonded to 2 bonding pair and it has 2 lone pair. So the class will be AB2E2. Next, you must determine your EPG. Okay, EPG, electron pair geometry, is when you add up your bonding pair plus lone pair. So when you add up these two values, you will get 4. So what is the shape if there is 4? If the total electron pair is 4, it will be tetrahedral. Okay, the link for the simulation is included in the description. So if you open this one, you open the website, okay, you choose the model, okay, and then again, there just now we have 4 total, kan, 4 electron pair. So I'm just going to put 4. So 4 here, this is what we call as tetrahedral. So if you look at your bottom left, electron geometry is tetrahedral lah. Okay. Next is we have to determine the molecular geometry or the shape. So for the molecular geometry, since we have lone pair on the central, the electron pair will not be the same as the molecular geometry. Okay. So to know the molecular geometry, it's actually easier for you to refer back to the EPG first lah. So tetrahedral, what's the shape? Okay, oxygen has 4 kan? 1, lepas tu 3 ni macam kaki ayam. 1, 2, 3. Okay, but then if you look back, the class here have 2 bonding pair. So it means we only want 2 bonds lah. Okay, so 2 bonding pair, 2 lone pair. So I'm just gonna remove the top and the bottom here. So top, bottom. Okay, so then this case, don't forget it is bonded to fluorine with the lone pair as well lah. Okay, so what's the name of the shape? So the shape is band or V shape. Okay, so for the molecular geometry, it's fine if you only answer only one lah. Band boleh, V shape pun boleh. So if you want to write down both pun, it's fine. It's the same thing lah. When we refer back to the simulation, again, OF2 have 2 bonding pair, 2 lone pair. So I'm going to remove 2 of my bonding pair. I'm going to add 2 my lone pair. So when I take molecular geometry, here it is called band. Okay. So we can see it is band lah. Why is V shape? Sebab bila kita kaca macam ni, nampak dia V shape here. So that's for question 1 Roman. Okay, question 2 Roman. Explain whether OF2 is a polar or non-polar molecule. Okay, so for polarity, if they ask you to explain, there are 3 points that you must discuss. The first point is that you have to mention the bond present. Is it polar bond or non-polar bond? Polar bond means it consists of 2 different atoms. For example, if I have my HF, Okay, so this bond consists of two different atoms. So this is polar bond. Non-polar bond consists of similar atom. So kalau polar bond HF, non-polar bond, for example, our oxygen. Here is example of non-polar lah. Okay, so next, so that's the first point. We have to mention whether polar ke non-polar. Second point, we have to mention about the dipole moment. Okay, so once we've known that it is polar bond, so it means that we can draw the dipole moment towards more electronegative atom. Electronegative atom ni ability to attract electron. So all group 17 is considered as electronegative atom lah. Why? Because the group 17 has 7 valence electron. See, so it only needs one more electron to achieve octet. So that's why high electronegativity. But for the element of period 2, the arrangement of electronegativity is SK015. Okay. So usually our syllabus banyak guna yang SK015 ni lah. So for OF2, first we have mentioned that the bond present is oxygen fluorine, right? We have oxygen fluorine here, oxygen fluorine here. So we have to first mention that oxygen fluorine is a polar bond. Once we have determined that it's a polar bond, we have to draw the dipole moment. So we have our oxygen and fluorine. Which one is more electronegative? So SK015. Okay, so fluorine is the most electronegative atom. Okay, in this case, our arrow will be towards fluorine. So now we have drawn the dipole moment, then we have to show lah. Then we can determine whether it can be cancelled out or not. So the arrow is towards this one. So the resultant dipole moment is actually towards downwards kan. So it cannot be cancelled out. For example, if I have my atom, for example, BCl2. For example lah, BeCl2. Okay, this arrow towards chlorine. This one cancel out sebab memang opposite direction kan. Okay, this one linear. But this one cannot be cancelled out because our resultant is towards downward. Okay, so we have to write down. So we have to write down the dipole moment cannot cancel each other, or mu is not equal to 0. Sebab yang ni towards downwards. For example, just now BeCl2 kan, ada arrow towards chlorine here, towards chlorine. This one cancel out, mu is equal to 0. Okay, so if it's not equal to 0, so it means that it is a polar molecule. So that is how you answer the question. Again, if you have to explain, so that there is 3 points. Okay, so that's the answer for question 2 Roman. Again, when they ask you to explain, first we have to mention about the polarity of the bond. The bond itself, bond yang one by one ni. So once you have mentioned the polar bond, then you have to draw the dipole moment towards more electronegative atom. Don't forget whether it cancel out or cannot cancel out. And don't forget, the last but not least, the conclusion lah. If it's not equal to 0, then it is polar. If it's equal to 0, it will be non-polar. Okay, so that is all for question B. Question C, aluminium and sodium are metals. Question 1 Roman, explain the formation of metallic bond in sodium using the electron C model. So first you have to explain the formation of the metallic bond. So what is actually a metallic bond? Metallic bond is the electrostatic force of attraction between positively charged Na plus and negatively charged C of electron. Okay, this case why specifically Na plus, because here it mentioned in sodium. So what is electron C model? So it means that you have to draw the electron C model lah. Not only for the explanation, you have to show based on a diagram. So this is the electron C model. So for the electron C model, you have to show the metal itself, but then for the metal, you have to show that it is in the positively charged lah. Because for this case, our sodium has already donate the electron, Na plus plus E minus. So for this case, for each one atom, it donate one electron. So that's why Na plus 1 electron, Na plus 1 electron, Na plus 1 electron. Okay. So when we're talking about the electron C model, supposedly electron C kan. Tapi for you, you don't have to draw until 20 sodium atom. Okay, minimum you only draw 6. So 6 atom means that we have 6 electron lah. For example, if the question asks for calcium. So kalau calcium, so calcium 2 plus, here the electron must be 2. Okay, so the number of electron must be depends on the number of the atom itself. Okay. So yang ini because for sodium only donate 1, so got 1 lah. Okay. Don't forget to label as well the electron as the delocalized or free moving electron. So usually in your notes you use delocalized. Delocalized tu maksudnya free moving lah. It is mobile. It can move around. Okay. So this is the basis of the metallic bond. Whereas there is the electrostatic force of attraction. Attraction between what? Between our positively charged cation, in this case our sodium plus, and negatively charged our C of electron. Okay, so that is about our metallic bonding. Question 2 Roman, why aluminium has higher boiling point than sodium? So for our metallic bond, there are two factors that we discuss, which is the strength of metallic bond. MB ni stands for metallic bond lah. The strength of metallic bond depends on the number of the valence electron, but inversely proportional to radius. Okay, why it is directly proportional to valence electron? Because for example, if I have many electron here, for example, I have my calcium, so it means that the number of electron is increasing kan, compared to the Na plus. So what happened is that since we have many electron present, so it means that there's a higher or stronger force of attraction lah between the cation and the electron. Lagi banyak negatif ni, lagi strong lah attraction dia. Okay, so how do we mention it out between aluminium dengan sodium? So based on the electronic configuration, we know that kalau aluminium is 13, so 1s2, 2s2, 2p6, 3s2, 3p1. Sodium 11, 1s2, 2s2, 2p6, 3s1. So the difference is actually about the valence electron lah. So it's fine if you only want to explain in terms of valence electron. Okay, that aluminium has 3, our sodium has 1. When aluminium has a higher valence electron compared to sodium, hence we know that the strength of metallic bond is directly proportional. So here, metallic bond for aluminium is stronger than sodium. So when it is stronger, then there is more energy lah needed to overcome the force of attraction. Then aluminium has a higher boiling point. Okay, but then again, there's only these 2 points lah. So it's either valence electron or radius. Radius pun boleh juga, because this one is actually both are on the same period, period 3. So across the period, if you remember chapter 3, pizzas, the size is getting smaller. So if the radius smaller, the strength of metallic bond pun increase. But then it will be a bit more straightforward kalau we're talking about valence electron. So that is all the solution for question 3 PSPM 2018-19.